On page 58 in your instruction book, we are talking about comparing functions. You guys watched the video last night and filled out your graphic organizer. The main focus of that graphic organizer is identifying your initial value, your starting point, and your rate of change, how much you are changing at each increment. At the bottom of your graphic organizer, it talked to you about how to compare two different functions, and you had two little boxes you had to fill out there. Now, this lesson is going to tell you all of that same information. It's just going to be presented a different way. Hopefully at the end of this, you're going to have it. Okay, so you have learned to identify a function. Look at this problem. Today was a snow day. Felicia decided to track the snowfall. There were already 2 inches of snow on the ground from a previous storm. Felicia measured the snow from today's storm at the end of each hour. She found that exactly 1.5 inches of snow fell each hour. If it snowed at this rate for 5 hours, how much snow was on the ground at the end of each hour? You use math. Use the math you already know to solve the problem. Because they're making a table. This is just a simple XY table. Inputs and outputs. The inputs are going to be the amount of time because she is tracking an event as it happens over time. So our X, or our input, is time. Now, the amount of snow on the ground is what we are tracking. That's our output. That's what we hope to find out. Now, an initial value is your starting point. It's what you had when you decided to track snowfall. She got up. Felicia said, you know what? I'm going to track this and see how much snow is falling. So she walks outside and there's already 2 inches of snow on the ground. Now, she's not tracking the 2 inches. That was her starting point. Okay, that's her initial value. So after that, she walked outside, there was 2 inches of snow on the ground. After that, she went outside each hour and she measured the snow again. And she found that exactly 1.5 inches of snow fell each hour. So when she went outside at 0 hours, there was 2 inches of snow. Then she went back in and an hour later she comes back outside. How much snow was there on the ground after that first hour? She said that 1.5 inches of snow fell each hour. So at 0 hours, there was 2 inches. After 1 hour, there should have been an additional 1.5 inches. So if you took your 2 inches and you added 1.5, there would have been 3.5 inches of snow on the ground after the first hour. Now, she's going to go back in the house, and an hour later, she's going to come back, and she's going to measure again. Well, when she measures again, there is an additional 1.5 inches of snow. So we add that to our 3.5, and now there's 5 inches of snow. So after 2 hours, we have gone from 2 inches of snow to 5 inches of snow. Another hour passes, another 1.5 inches of snow falls. Now we're at 7.5 inches of snow. No, we're not. We're at 6.5. So we come back an hour later, another 1.5 inches of snow has fell, and now we're at 8 inches of snow. And the final hour, another 1.5 inches falls, and she has a total of 9.5 inches of snow on the ground. Notice the pattern of adding 1.5 inches each hour. The initial value, the starting point, was 2 inches. The rate of change, how much snow was falling at each hour, is 1.5. Your rate of change is your pattern. Plus 1.5, plus 1.5, plus 1.5, plus 1.5, plus 1.5. Now, on your graphic organizer, you had 3 blanks. Now, on your graphic organizer, you had a blank that said rate of change can be, and then there was a blank and it said positive under it. Positive, think about the snow. Was we increasing or decreasing? We was increasing. Increasing is positive, okay? A positive rate of change is increasing. So on that blank on your graphic organizer where it says positive, you need to write increasing above that. If it was going down, it would be negative and it would be decreasing. And then the last one where it says no change, that needs to say constant. Okay, write constant above that one. And that fixes your graphic organizer. So we have an initial value, a starting point of 2 inches, and we have a rate of change at 1.5 inches per hour. And it is a positive change because it is increasing the amount of snow that's on the ground. So A says in the table, 0 represents the time when the storm started. How much snow was on the ground? There was 2 inches. They told us that in the problem. How much snow fell in the first hour? 1.5 inches. So how much snow was on the ground when she measured at the end of the first hour? There was 2, and it added 1.5 to give us 3.5 inches. C says, describe how you can use addition to find the amount of snow on the ground at the end of each hour. Well, you add 1.5 inches for each hour that passes. So what it looks like is 2, we started with 2, plus 1.5, plus 1.5, plus 1.5, plus 1.5, and I'm going to run out of room, plus 1.5. And that's 1.5 addition for each of the 5 hours. D says, suppose you multiply each hour in the table by the rate 1.5 inches per hour. What else do you have to do to find the total amount of snow? Now what they're saying here is instead of adding 1.5 for each hour, okay, instead of adding it 5 times, we could say 1.5 inches fell for 5 hours. What is left that we haven't accounted for when we multiply by 1.5? The initial value is what's left because we need to add that to our total as well. 1.5 inches of snow fell for 5 hours plus the 2 inches that was already on the ground gives you the total amount of snow. Then E says fill in the blanks to write an equation for the situation. Let S equal the amount of snow on the ground and in inches and H equal the hour. Now they're going to rearrange the order here a little bit. The total amount of snow is equal to the 2 inches we started with plus 1.5 inches per hour. And we just wrote an equation that would allow us to track snowfall. Now that we have an equation, if that storm kept going for another 5 hours, giving us a 10-hour storm, we could predict the snowfall at 1.5 times 10 plus 2. And that would tell us how much snow we would expect there to be after 10 hours. Okay? Now we can make predictions. We've used a pattern, the rate of change, and the initial value to give us something we can use later on. Okay, page 59. You are familiar with proportional relationships that start at 0, 0. These are the ones we talked about on the last lesson. For example, 0 hours worked means $0 earned. The problem on the previous page does not include 0, 0. The problem states that there was already 2 inches of snow on the ground at 0 hours. This function starts at 0, 2. So the initial value, or the starting output value, is 2. Now you should have that in your graphic organizer. The initial value is the starting output value. It's what you start with. Now, the snowfall problem on a graph, they've just taken their table and they've made a graph. Notice that the initial value, the starting amount, is right here. Okay, that's your initial value. Notice its location. Your initial value will always be on the y-axis. The initial value is the point where your graph crosses or touches the y-axis. So initial value is going to be, it's called your y-intercept. The initial value is the y-intercept. It's the point the graph touches the y-axis. That's important. Now, the rate of change, they're talking about it down here. The graph also shows the rate of change. And the rate of change is how much your function is changing at each increment. It's like how much snow is falling for each hour of time that passes. It's written as a ratio, and they're going to talk about that down here. The x and y values change at different rates, but the ratio of these changes is always the same. Your rate of change is the ratio of the change. From point to point, the y values change by 1.5 units and the x values change by 1 unit. So the rate of change is 1.5 over 1, or 1.5. Now, on your graphic organizer, I gave you something that looked a little bit different. It was called delta y over delta x. Delta y means change in y, and delta x means change in x. Delta y is your change in y. Guys, that's vertical, up and down. Your change in x, or your delta x, is horizontal, which is left and right. Delta y in this example was how much did we go up from 2 to 3.5. Okay, that's your up. It went up, or positive 1.5. That's your delta y. It went up positive 1.5. And then your change in x, your delta x, is how much it went from left to right. From 0 to 1 was up 1. So it changed 1 unit. So 1 unit in x was a 1.5 unit change in y. Okay, delta y over delta x. Change in y over change in x.